The first thing we need to remember is vector AB, not for this question, just vector AB can be written as vector AO plus vector OB. That's something we've just got to remember. Do we kind of remember that? As long as these two letters or these two things are the same, then we're allowed to add any two vectors. The only other thing you need to remember is if I need to go from vector AB to another vector through rotation, all I do is get vector, let's call it CD, and I multiply that by R cis theta times vector AB. What I've just done there is I could have increased the size by R or decreased the size by R, if you want to make a half, let's say. And theta would mean I've rotated the angle. So this is how this would look like. Imagine I had vector AB like this, A, B. I wanted to get it to here, C, D. What I would have done is got vector AB, multiplied it by some sort of R length. Let's just say in this case I've reduced it, so now it's looking like that. You times it by R, and by timesing it by cis theta, you're rotating it by whatever the angle is. Theta. Make sense? Let's see. In this case, in the Argand diagram, OPQR is a rectangle. Already there's a few things you've got to know about rectangles. They're right angled, opposite sides are equal, blah, blah, blah. Where 2 times OR is equal to 3 times OP. It's usually confusing for students, but I think it makes sense. Two times of these sides is equal to 3 times of these sides. Or in other words, OR is 1.5 times the size of OP. Most students don't see that, but why wouldn't you? OR is 1.5 times OP. It's a lot easier to think of it like that. Sounds good? So technically, before I continue it, if I was to say, hey, I've got OP, can you get me the size of OR? You'd be like, yeah, vector OP, to get to vector OR, just times it by 1.5. True? That would be this. For example, if I got OP times it by 1.5, there it is. But that's wrong because I need to rotate it now. But anyways, we'll talk about that now. But that's what we've got so far. The vertex P corresponds to the complex number W, or omega. So that means vector OP is actually equal to omega. All good so far? We can get to that stage? What complex number corresponds to the vertex R? Oh, so easy. R has to start from the origin, so OR equals 3 over 2, right? Because you've got to make OP larger. So 3 over 2 times cis what? 90 degrees. Oh, don't forget, I should have said that. Anti-clockwise is positive, as we have been assuming usually. Cis 90, and then of what? W, of OP. Isn't OR 1.5 times, rotate at 90 degrees of OP? Done, you're finished. Cis 90, what you'll learn in this topic as you keep doing a few, cis 90 is I. So 3 over 2 omega I. Done. Questions? You sure? Okay, let's try double line. What complex number corresponds to the intersection S of the diagonals OQ and PR? Okay, wait. So what do I need to find? Complex number S, so which means OS. I need to eventually find vector OS. So, because complex numbers start from the origin, right? So, OS. Okay, so to find OS, which is somewhere here, you know that that is the intersection of these diagonals. diagonals in a rectangle bisect or not? It's the property I'm trying to remember. Do diagonals bisect? I think they do. Don't they? Someone confirm? Agree, disagree, don't know? Do diagonals in a rectangle bisect each other? That means cut in half? I think they do. I don't think it's a right angle. I think for a rhombus it's a right angle. For a square it's a right angle as well, but I don't think for a rectangle. So I think if they just cut in half, I think we're good. All right, so vector OS is going to be half of vector what? OQ. OQ. Vector OS is half of vector OQ. So really, what are we trying to find? OQ, not OS. So vector OQ. Now, vector OQ. Vector OQ is equal to vector OP plus vector. Yes, vector OQ is equal to vector OP plus vector PQ. What does vector OP equal to again? What does vector PQ equal to? Isn't vector PQ the same as vector OR? Isn't vector OR the same as vector PQ? Same? So then that equals to W plus 3 on 2 WI. And I think you guys can see we're pretty much one step away now. Vector OS is equal to half of W plus 3 WI on 2, which equals to W on 2 plus 3 WI on 4. I think by just doing that, I realize a problem that I think students do have. It's changing the complex number to vectors. I think that's something we'll look into next week. Just understanding the difference between a complex number to the vector. But you can, it seemed like you guys were okay with the math other than that. It was just that first line. Yeah? Okay, fair enough.